Welcome to this episode of Brain, Music and Learning, where I met Professor Susan Hespos in Sydney in the Mark's Baby Lab, and she tested me on some of her experiments.
This is a really fun study where the kids are asked to play a game, and you have to figure out the rule. So like a kid, I'm going to ask you to figure out the rule. So this is the first thing. So you say, see that? And then you say, do you see these two? Which one of these two is more like this one? So
I would say this one.
Excellent.
Yes.
Now, you happen to get it right on the very first shot, so good on you. And so, but a lot of people need a couple to get through. So, normally I take the cards away, but I don't want to mess with the order. So here's another one. And then do you see these two? Which one of these two is more like this one? So which one would you pick here?
I would pick this
you
one.
still got the same rule, and it's still working for you. So you're good. So basically what this is about is it's called Relational Match to Sample Task. And essentially it's an abstract rule, right? So so actually, why don't you tell me, why did you pick the right one on both of those? What do you think the rule is about?
I think it's about being the same or different.
Yeah, exactly. Now, we didn't say that beforehand.
Yeah.
I can get undergraduates to get this wrong. Actually, some of the parents get it wrong too, so that's fine. But if I go through a couple more trials, you sort of say, like, is it the color? Is it the shape? Is it the pointy things? And that after multiple trials, you would sort of figure out, like, okay, no, it can only be one thing. And that's because we set it up that way. So obviously on this side, you would pick this one because these are same and these are same and these are different. So there's ways to make even adults mess up on this task. So let's just say I had a is that a hexagon? Yeah. If I had a hexagon and I had a hexagon in a circle here,
then that would be the right answer.
Yeah, because all of us, including kids, have an object bias. We go for an identity match because it's just easier. Actually, a lot of other species do that too, but only humans, and really only preschoolers and older, are good at this task. And it takes, we've run hundreds of kids on this right now, and basically it takes 4.5-year-olds. They usually get it in the first couple trials. There's no significant difference from the first 3 trials to the last 3 trials. Wow. So that's pretty cool that they're getting it. Some of them don't get it at all. Yeah. I'm not going to say it's like 100%. All of us have run research. We know nothing is 100% ever. So in this particular task, we're looking at what it is that facilitates seeing the relationship versus doesn't. So here we don't have any object matches because that just... it derails them completely. It derails undergraduates. So fine. In this task, we do pairs. And then what we do later on in the task is go to triplets. So I'll show you these. So, sorry, I'm just trying to keep them all in order for running a participant later. But so I'd say, see this one, see these two, which one of these two is more like this one? Yeah. So same rule, you would go different and different and hopefully pick this one. That's great. And the reason we're looking at 4.5-year-olds to 5.5-year-olds right now in this task is that all 5.5-year-olds nail it. They just get it. They're really good at it. If kids get 100%, we don't learn anything. Yeah. So fine. One of the things that we did learn about doing pairs with 5-year-olds is that when we ask them, like, well, why'd you pick that one? Just like I asked you before. If they use the words same and different, those are correlated with the kids that get higher scores. Okay. So language is probably helping with this task. And if they have that in their vocabulary before they walk in the door, they're going to do really well in this task. Okay. Some of the kids, I've seen it in the data, but it's just like an individual kid kind of thing. They learn it during, they're wrong at first, and then they're like, oh, and so I've seen every pattern in the data, but if they have that language during the justification trials, they pretty much have got it down. And so it means that they had the concept before they came in, and on trial 1 they nailed it, or maybe 2 or 3 because kids are variable. We tested, so the reason we're testing, so 5.5-year-olds do really well. And it was interesting to discover that language is predictive of their performance. So now we don't like looking at the kids that get 100%. We like looking at before that and what we can do to facilitate that performance. And so that's why we're looking at 4.5-year-olds right now. So some of them get it, some of them don't. If they have the language, it's absolutely, those are the ones that succeed. If we do pairs followed by triplets, we've only run a couple of kids, but it seems to be working pretty well. If we do pairs all the way through, they get it, significantly above chance, so that's great. If you do triplets first, And then pairs, they wipe out. And I think it could be a cognitive load issue, that this is just way too much information to process because it's 50% more objects, right? And so my original hypothesis was, well, there's a whole lot more, like here, let's see, this one's the same. There's a lot more same going on in this card, right? Like these two are the same, and these two are the same, and these two are the same, and the whole thing is the same. So that's a lot of redundant information. I was like, they're going to nail it. Well, I'm here to tell you they absolutely don't. But if you flip it, you do pairs. They build up their confidence, and they've gone through a couple of trials. Now they're ready to absorb more information. So this is the kind of stuff that teachers can use, right? That kids, if there is an identity match, if there's like an easy answer, they always go there first, because thinking is really hard. And nobody wants to think really hard unless they have to. And so number knowledge, understanding shapes, reading, all of these things are really, really, really hard. And so we have to drill kids on this until they actually get it. And so what's helpful about knowing this stuff as teachers is this idea that if you understand that relational stuff is hard, you can get kids to focus on it and really champion them going through it. The other things that we know that help are multiple exemplars. So show them, if you showed them ahead of time, you said, look, these are the same. Can you see why they're the same? And hang on. These are also the same. Can you compare these two and tell me why they're both the same? If you get a kid to express that, they're so much more likely to see the abstract rule and apply it afterwards. If you have an object match, you're in trouble. They're just not going to get it. And so, hang on, I just want to make sure I put this back correctly. So as teachers, multiple exemplars, asking the kid to do the comparison, like showing them two things that are from the same category or whatever rule it is that you're trying to teach them. And, can you see why both of these are addition? Can you see why both of these are the same sounding word? Getting them to do that comparison themselves is going to be more likely to allow them to generalize it to new situations. And that's when, kids really take off. And this is uniquely human. We can train other species to do these tasks. With kids, it takes 2-3 trials. With chimpanzees, it takes 60,000 trials.
Wow.
No, nobody wants to do 60,000 trials. Nobody has that time.
Yes.
So there's something magical going on in the kids, and it is unique. And so that's what's really neat about it. And so some of the studies that we're doing on this is kids learn it really early. Language certainly helps. But language can also derail you. If you say, get the kid focusing on the cross, they don't even look at the rest of the stuff in there. So try to get them off their object focus and get them onto a rule focus, and comparison is the best way to do that.
So these rules are kind of mathematical also? So this is like the baby steps of mathematics?
Yes. So my theoretical, but my theoretical sense is that it's even bigger than math. It's relational. So we could talk about it as numbers are all relational, right? And so it's learning the patterns in number, and that's what's success in math. The success in reading, learning the patterns, right? The cadence of writing, even, for 12th graders, right? It's understanding the structure of a paragraph, structure of a sentence, the structure of a paragraph, the structure of a paper, right? Or a storyline. So all of this is relational, and it's, I think, the same mechanism driving all of it. It's this idea that if you do comparison, it works in business school cases when you say, why was this negotiation success? Compare these two negotiation cases and tell me what's similar about them. If you do that process, you're going to have a negotiation rule that you can apply broadly across all things. You could also say to a kid, you know what, if you take something from this side of the equation and move it over here, the equal signs, you have to balance it. If you teach kids those sort of principles that apply broadly, that's when the magic happens, where the kids get really excited about learning, but they also have to be really motivated, because if they can just memorize and regurgitate, they're going to, and they're really good at it. They're actually better than adults in the really early learning phases. So do you guys have this game, we call it memory, where you have like a whole bunch of cards and you put them down on a table, and there's 2 of each card, and you have to flip over 2 cards, and if you match them, you get to go again, but if you don't match them, you flip them back and somebody else has to go. I really want to run this study, but I know that it's true from having played this game with many kids. prior to learning how to read, kids have better memories than you and me as literate adults.
Yes.
Illiterate adults also have amazing memories because they can't they can't write down the grocery list. They have to memorize things. So there is this age around 4 or 5 when kids are not proficient readers yet, and they still have amazing memories. And if you play this memory game with you, watch out. They're going to beat you.
Yes, I've lost this game so many times.
Isn't this great? But that's what's so fascinating about, because I'll sit there and I'll be like, all right, I'm really going to sit down and concentrate on this. Yeah. And my son would still beat me. And he was so nonchalant about, oh, like, I think these 2 match. Oh, I got another one. Oh, I got another one. Oh, it drove me. Me nuts. But I think there's an amazing study there because their memory skills are fascinating. And then what happens to it? Well, they learn something more relational, like how to read or how to do number. Yeah. And that transcends that ability because now we can write things down that we have to remember. And let's give the kids a win. When they're brilliant, it's great. Yeah. So that's that one. Is that the kind of stuff you wanted to know?
Yes, exactly.
Excellent.
Exactly. Yes.
These are really fun tasks. I think that there is an ability to teach relational learning and analogy broadly. And that analogy is a uniquely human ability that other species don't have. If you align examples in a way that makes sense to kids, you can give kids 10 examples, but if they don't see what's comparison and the same about all of them, you're wasting your breath. Yeah. So asking kids, and this is hard in a classroom, but asking them to do the comparison themselves is one of the best ways to make that structure emerge and be obvious to them. Mm-hmm. And I'm sure there are studies that, if you hear another kid say it, maybe you will get it, maybe you won't. But I do know from doing individual testing in a lab, if you can get the kid to explain it, that child will get it. Yeah. And then maybe other kids will pick up on it too. Yeah. And it is a skill. So it's a teachable skill that all humans come equipped to acquire. And then whatever relations you want to teach them, they'll pick up, right? So if you think about cultural rules, if you think about number knowledge, if you think about art ideas, music ideas, all of these things have rules and a structure that is somewhat implicit at first, and then but can be explicitly taught in a classroom, and then that abstract rule can be generalized anywhere, and that's what's really fascinating about these kind of studies.
Yes, and the knowing the rules well means that you can also break the rules, and that's when you can make something important.
Exactly. Well, so Dedry Gentner, who's one of my collaborators on these projects, went back and looked at Kepler's notebooks when he was making the insight. Right. It was between the solar system and an atom was the analogy that he was making. But it is this idea of that's where induction is, right? Mm-hmm. So you say, here's an atom, and it has a nucleus and it has electrons that speed around it because of an attractive force between them. So there's that structure. And now let's look at a solar system, and you've got the sun, you've got planets zipping around it due to an attractive force, between them. And so there's alignable things to compare across these two things. Now, if you want an analogy to fail miserably, you're like, well, atoms are little and solar systems are huge. So you're like, okay, there's nothing to buy there. But some of our most notable human breakthroughs are this ability to do inductive reasoning and to go, say like, okay, well, if the hierarchical structure is an attractive force between these things, could it be the same for the solar system or from the solar system down to the atom? I'm pretty sure solar system came first in the history of science. Yes. But anyways, it is this idea that you can look at the hierarchy and say, well, this one's got this structure and these things are similar, but what about this? And it allows you to come up with a brand new idea. Yeah. And so this is at all levels of science and art, the fundamental basis of what allows us to create new and fascinating things. Yeah. So
I also have to ask about, you are now talking mainly about visual things. Mm-hmm. So what about the auditory system? Do you think that this kind of similar rules could be taught?
I could just go bold, but I do think it is a domain general mechanism for learning. So yes, I think it works in learning languages. I think it works in just about any domain that you can see these relations. So it's all about the idea of making comparisons between things. It can work for ideas, it can work for objects, it can work for sounds. there's no limit. It could probably work for touch. I'm trying to think about how that would work. But any of the senses I think could do it. It's you're perceiving something and seeing a relation between them. And it's all about whether or not you're aligning the common structure across the two entities. And so, it's not limited by any particular. Vision is an easy example. But I think it works for just about everything.
And when we talk about languages, so adults are usually very visual language users. So we
haven't talked to Paula yet. She's a total auditory language user. But
so that's the problem kind of for adults, that we would like to put it in the visual format in order for us to see how the relations are. But children are listening to the relations when they are listening to music, when they are listening to language. So
I think there are people that have predilections. Some people are more auditory processors, some of them are more visual processors. I think there's even fields, and who knows if you gravitate towards a field that's more visual because you're a visual thinker or vice versa. I'm sure there's an amount of flexibility between them as well. But I do think that especially if you were to take, look at the history of science, right? You can look at, vision is probably one of the most well understood senses, right? In terms of what we know at the neuronal level, as well as up through sort of the conceptual level. And some of the most amazing breakthroughs in cognitive science have been taking what we know about vision and making an inductive analogy to what you know about auditory stuff. And there's fascinating stuff where, vision is spatial, but auditory can be temporal. And so what does that actually mean and how does that translate? So I just think it's a rich opportunity to look at these things. And there are some ways where it is very alignable, and there's ways where it simply isn't, right? And there's different neurological techniques for measuring this stuff too, right? So the visual people are going to be more about doing fMRI, maybe looking at bold signal and localization, whereas the auditory people, EEG really lends itself better to that because it's got such beautiful temporal synchrony. So it just depends. You sort of have to work whatever advantage you have. So it's fascinating stuff. It's really fun. What else do you want to hear about?
So maybe my final question is about your message to teachers.
My message to teachers is teach relational learning. Try to, as much as you can, leverage comparison across examples and let the kids play with the alignment and come up with after you use alignment and asking kids compare these two things, what do you think? You can highlight with suggestions from the class the things that are alignable and you champion those. And when they're like, it's pointy, or I like orange, or you let those ones fall by the wayside because those tend to be featural. And you champion the ones like, ooh, more of this kind of stuff. So why are they the same? And get them to sort of elaborate on those kinds of ideas. It's a way of playing with the classroom at sort of like a higher level. And it allows, what's really fascinating is that this will appeal to some kids. There's different ways to, we all know as developmentalists, right? There's no single path to learning. But some kids are really relational from the get-go. And some kids are like memorization, regurgitation. I need it to be very, And the relational kids, they tend to be multilingual or multicultural. And it's because they're used to seeing, they've seen two examples in life, right? And they know okay, well, we eat this kind of food when we're at grandma's house. We eat this kind of food when we're at home. And so they see that it's both food, but they see, things that are alignable and things that aren't alignable. And so I've seen it when I've gone into classrooms myself. The kids that were, my son's classroom was one that was half Mexican and half American, or white kids. And oh my gosh, the Mexican kids who were bicultural were so good at thinking at a relational level. And our elementary school systems don't reinforce that. We do a lot of memorization and regurgitation. But I don't know, the kind of stuff that brings me excitement and joy in a classroom is not memorization or regurgitation. Some kids are really good at memory. Like I said, with the memory test, they beat me. So that is fascinating, and that can be championed and has importance as well. But my personal preference is to train their ability to see patterns. And the kids will surprise you. The patterns that they come up with are not the patterns that you and I come up with. And so I think that that's wonderful.
Yeah. Do you think that it could be related to bilingualism? Because when you are bilingual, you are actually handling two languages which have some similarities and some differences.
Exactly. And it's all of these alignments that help them. I also think it has to do with executive control of suppressing one language or understanding that there's two different perspectives. I think all of these things, studies have been done on this stuff in the field, and it's still hotly debated.
Yeah.
Sometimes the effect is there, sometimes the effect is not there. I think we as a field are getting a little bit better about being welcoming to diverse samples.
Yes.
Like you said in your talk, it's a lot of the people, 92% of the people that came through my lab in the United States were university degree or higher. That is not the population at large.
No.
And what's really fascinating is once we get into more diverse populations, at least in the United States, and I don't know if it's true here in Australia, but you're more likely to find multiculturalism at the lower SESs.
Yes.
And so that's fascinating too, because this is an opportunity for them to actually be catapulted to the top of the class instead of vice versa.
Yeah.
And I think it's always good to shake things up in a classroom, because that's how there's no single path of development. So the way that we're going to succeed in terms of making all boats rise is to offer a variety of learning opportunities.
Yeah. That sounds wonderful.
Yay!
Thank you.
That was a pleasure.
Wonderful.